Alright, so now we are going to learn about finding the solution of linear equations that have two variables each, and then we are going to learn about solving them using algebraic techniques. There are essentially three techniques. One is called solution by substitution method, second is called solution by elimination method, and third is called solution by cross multiplication. We will focus less on the cross multiplication techniques because of two reasons. One is that it is simply an extension of the elimination method. And the second and important reason is cross multiplication. It requires you to memorize certain formulas. And in my opinion, whenever we have to memorize something in mathematics, that means it's not a long-term solution. So that is why we are going to focus more on learning about substitution or elimination method. So the substitution method first. Let's say my two equations that have been given to me are 2x minus 5y is equal to 23, and the second equation is x plus 3y is equal to 17. Label this as equation 1 and equation 2. Okay, in substitution, the technique is that out of these two equations that have been assigned, take any one of those two equations and define one variable with respect to the other variable. Okay, so at this stage, you can pick any one of those two equations. I'm going to pick on second equation because it is easier to define one variable with respect to the other variable. So when you write the equation number 2, it is x plus 3y is equal to 17, or you can rewrite this to be x is equal to 17 minus 3y. All you're doing is simply transposing your variable 3y or the term 3y onto the other side of the equation. Okay, so from this point, remember, this is the value of variable x. Okay, now let's take a look at my equation first. Equation first can be rewritten as 2 times the value of x. I'll leave it blank for a second. Less 5y is equal to 23. And then transfer this value of x that you obtained in your step 1, or label this as your equation number 3, right? So x is equal to 17 minus 3y. I will simply transfer that value here. Okay, so now you have one equation that is only in terms of variable y, correct? So let's simplify this. This will reduce down to 2 times 17 will be 34, minus 2 times negative 3 will be negative 6y, minus 5y as it is from here is equal to 23. So negative 6y and negative 5y, they will make negative 11y, and that is equal to 23 minus 34. Why? Because you are simply transferring this constant value onto the other side of the equation, right? And when you do this transpose, the sign on the 34 will reverse. It becomes negative now, right? So when you solve this, 23 minus 34 will be negative 11. Now at this stage, you will simply divide both sides of this equation with negative 11, right? And what happens then? This negative will cancel. Negative 11 will also cancel here, and you simply obtain y is equal to 1. So this is one unique value of y you have obtained that satisfies, let's say this was my equation number 4, right? Now you have obtained a unique value of y. What you can do is simply transfer this value of y in your equation number 3, right here. And when you do this, you obtain x is equal to 17 minus 3 times the value of y, which is 1 now, right? Or it is equal to 17 minus 3, which is 14. So by the way of this substitution method, you have obtained your unique solution to be x is equal to 14 and y is equal to 1, right? As simple as it is. And the steps in this substitution method, if you were to recap this whole thing as, number 1, take one of those two equations and define one variable with respect to the other variable. And that's what you obtain here in equation number 3. So using that value of x as one of the variable, you substitute this value of x into the other equation. Solving that will give you the unique solution in terms of one of those variables, which you can substitute back in your original equations to find the value of your other variable. So this is what is known as substitution method. Alright, so let us take an example to understand the elimination technique. So here my system of equations is equation 1 and equation 2. In this step, what we do is we look at these two equations at the same time and we decide which one of these two variables we want to pick so that we can make the coefficients of that specific variable equal in both of these equations. Okay, you can pick any one of those variables. You can pick x or you can pick y. It doesn't matter, it will lead you to the same solution. All right, I'm going to pick on the value of x. So what I do is I'm going to multiply the equation 1 with 3, and then I'm going to multiply the equation 2 with a value of 4. It is not a coincidence that I picked these numbers. The value of this multiplication 3, it comes from the coefficient that I have in equation 2 of my variable x. And this value of constant 4, it comes from the coefficient that I have in my equation 1 of variable x. Okay. So as you do this, what you obtain is 3 times 4x will be 12x plus 21y is equal to 135. Label it as equation 3, and then you will obtain another equation, the equation 4, that will be 12x minus 8y is equal to 72. Okay, so these two equations, the equation 4 is equivalent to equation 2 and equation 3 is equivalent to equation 1, right? At this stage, what I'll do is I'll simply subtract the equation 4 from equation 1. And when you do this, what you obtain is a net result of 12x from equation 3, negative 12x from equation 4, because you're simply multiplying this negative sign which is outside the parenthesis, right? And then you obtain plus 21y from equation 3, and then you obtain plus 8y from equation 4, because this negative will multiply with the negative inside the parenthesis to make it a positive, right? Then there is an equal sign, you have 135 minus 72. Now when you simplify this 12x will cancel out, right? And what you obtain is 21 and 8 will make it 29y, and that is equal to 63. And the reason it is called as elimination method is because you have eliminated one variable from this pair of linear equations, right? So now you obtain this unique solution for the value of y, and when you obtain this, it becomes y is equal to 63 over 29, and that is equal to 2.17. Okay. So now you see that you have obtained a unique value of y for which this pair of equations will satisfy, right? And then you can substitute that value of y in any one of those original equations. So let me pick my second equation, 3x minus 2y is equal to 18. Substituting this value of y gives you 3x minus 2 times 2.17 is equal to 18. Or alternatively, you can say that 3x is equal to 18 plus 2 times 2.17. Solving this gives you 3x is equal to 22.34, and then that gives you a value of x is equal to 22.34 divided by 3, or in other words, this is 7.45. So with these solution steps, you have obtained your unique solution to be x is equal to 7.45 and y is equal to 2.17. And this is the solution that you have obtained using the elimination method. So the key steps in this solution process, in the elimination process, were pick any one of those variables that have been assigned to you in your pair of linear equations, make their coefficients equal for that one specific variable, add or subtract so that you can eliminate that variable from your system of linear equations to obtain your unique solution of the remainder of the variable. Okay. And then using that value of the remainder of the variable, substitute it back in one of your equations to obtain your final solution. So this is what is known as solving a pair of linear equations using the elimination technique. So let us talk about our third and final method of solving equations using cross multiplication. You will find it very much similar to elimination, except for the fact that in the end you are being given a solution in general form, and that gives you the solution for the unique value of x and y, but you are required to memorize these two formulas. Okay. So if these are my equations, equation 1 and 2, in the first step, what you're doing is you're multiplying each one of them with a constant, and the constant is coming from the opposite equation, right? So equation 1 is being multiplied with the value b2, and equation 2 is multiplying with the value of b1. And this b1 and b2 are coming right from here. Okay. With the help of these multiplication, then you obtain your Next set of equations, say equation number 3 and equation number 4, which are equivalent to 1 and 2 respectively, right? And then you subtract one from the another to finally arrive at this solution and the solution in general form is as shown here, x is equal to something and y is equal to something. But you see, you have to memorize x is equal to b1 times c2 minus b2 times c1. So that is why I will say that this solution, even though okay, but it is not one of my preferred method of solving system of linear equations. We will rather take the approach of either the remembering the steps on substitution and elimination because it comes intuitively to you. Okay. So with that, we will take a pause here, and this is an introduction to you how to solve a system of linear equations using algebraic methods.